Hey guys, so this video is all about factoring polynomials. Factoring is where we're going to go with quadratic equations that we've been analyzing for a while. And it's used to solve for x. But this video is just about factoring. Okay? Now, we factor things two different ways. By finding the greatest common factor and by grouping. In each case, we need to know what the greatest common factor is. So for an example of this, we're just going to use some numbers. So greatest common factor is often used when working with fractions, least common denominator, that sort of thing. Greatest common factor means that we're going to take the biggest number out of this. So if we're looking between 6 and 18, well, the greatest common factor, well, a factor means what number goes into both of these? Well, 3 goes into both of these, right? 2 goes into both of these, but that's not the greatest common factor. I can divide 6 by 6. I can also divide 18 by 6 and get a number, right? It's what number can I divide out of these two things, okay? So the greatest common factor for this is 6, okay? A factor is a number that we can multiply to make other numbers. So in this case, 6 is really 6 times 1, and 18 is 6 times 3. You notice in both of these, 6 is common. I can also look at it like here, okay? 15 and 25. If I do it this way, okay, how do I get 15? Well, I can break 15 into a variety of ways. Well, 1 times 15, those are factors, 1 times 15, okay? Not 2, 3 times 5, okay, those are factors, okay? And there's no other factors for this. 24, on the other hand, I can break down into 1 and 24. Okay, so 1's a common factor there. Okay, 2 and 12. Well, there's no common factors there. 3 and 8. Ooh, there are common factors there. And 6 and 4. Okay, so what's the greatest common factor? The greatest common factor in both of these lists? It's 3. Okay, so the greatest common factor here is 3. The trick comes when you're dealing with x's. X to the third, x to the fifth. Well, you have to remember what x to the third really means. This means x times x times x. Okay? That's x to the third. X to the fifth is x times x times x times x times x. X 5 times. So what we're trying to figure out is what is common. What is the most common thing in both lists? Well, this list has 3 x's. This list has 3 x's. So the greatest common factor here is x times x times x, or x to the third. Because x to the third is in both of these numbers. Just like 3 is in both of these numbers. 6 is in both of these numbers. So that's what greatest common factor is. So when it comes down to factoring a polynomial, is also known as undistributing the greatest common factor. Okay, so first off, a polynomial just means a bunch of things added together with x's and y's and squares and that sort of thing. Poly meaning many, nomial meaning terms, so more than one term. In this case, for this number 1 here, okay, it has 2 terms. It's a binomial. Okay, and we look. Okay, what is the greatest common factor in both of these terms? Well, in this case, 24 and 48. those are numbers we can break down. And both of them have 24 in it. Okay, 24 times 1, 24 times 2. That's my greatest common factor. So I'm going to say, okay, 24, and then it's x and y. Okay, those don't have any common terms. So I'm going to take out a 24. I'm going to put it in parentheses. What is left if I take out a 24? Or if I divide each term by 24? Well, in this case, x is just left. In this case, 48 divided by 24 is 2y. So what you might recognize is we've been distributing in. Factoring is undistributing, taking out what we multiplied into a polynomial. In this case, there's 3 terms, a trinomial. And we have to look at each one of these terms. Now, what we look at is, the first we look at the numbers. Second, we look at the variables. Okay? So in this case, pull you a little closer here. In this case, 31 and negative 6. Again, it's not a minus 6, it's a negative 6. Now, if you notice, 31 and negative 6, we really don't have any common factors other than 1. Yes, 6 goes into 30 5 times, but 6 doesn't go into 1. So the greatest common factor has to go into all of the terms. So in this case, I can't factor out a number. I can also look at the m's. This is 30m, this is m squared, and this is 6p. You notice that there's no m's. Well, that means there's no common m throughout that, so I can't factor that out. This is p squared, this is p, and this is p. You see how there's p's in each term. That means I can factor out a p. In this case, this is p squared, this is p, and this is p. So there's 1 p in these 2 terms and 2 here. So the common is just having one of them. So I'm going to factor out a p. The 30m stays. If I take away 1p from 2 p's, there's only 1 p left, plus m squared. Again, I didn't touch my m's. If I take away this p, there's nothing left, minus 6. Same reasoning here. That is a factored trinomial, meaning that I pulled out all the things that I can pull out. For number 3, again, I look at the numbers first. There's an invisible 1 there, negative 18, and positive 22. There's no common factors there. What is common is the q's. Q to the 4th, q to the 3rd, and this is secretly q to the 1st. So there's 1 q common in all of those. So I'm going to pull out 1 q. If I pull out 1 q, there's 3 q's left here, minus 18 q squared, plus if I pull out this q, it's only 22. Okay? So we're going to repeat that throughout this process with binomials, trinomials. What you have to recognize is that you have to look at the numbers and then you have to look at the variables. So for 4, I can recognize 9 and 3 having a greatest common factor of 3. And x squared and x having a common factor of 1x. Well, what's left in there? Well, if I divide 9 by 3, I get 3. I take 1x away, x. Oh, now I'm taking a 3 out of there. So what's left? Well, the minus sign is left, so it's minus something. What's 3 divided by 3? 1. Okay, you have to think of that as division. Okay, 3 divided by 3 is 1. There is a number there. If there were 2 terms here, there need to be 2 terms here. Okay, and then the x's, if I pull that 1x out, I'm left. I'm done. Okay. In this case, again, I look at the numbers, 4, 6, and 8. Okay, 4 goes into 8, but 4 does not go evenly into 6. So what you have to recognize is that there's a common 2 there. And that's the only number that's common, because they're all even. This has an M, this has a P, this has an MP. Well, there's no common M's through all these terms or P's through all these terms. So everything else stays. So really, if I factor out a 2, I'm just taking and dividing all of these terms by 2. So it would be 2m plus 3p minus 4np. For 6, again, it's a binomial, 2 terms. So I know in my parentheses, I'm going to have 2 things there. What's common amongst 45 and 15? Well, 5 is one. 3 is another. But that's not the most common. 15 will go into both of those numbers. So I can factor out a 15. And then I have an r cubed and an r squared. Well, r squared is the lowest exponent. So there are 2 r's, or r squared, common in both of those. So I take 45, divide by 15, I get 3. R to the third divided by r to the second is r. And then 15 divided by 15 is 1. R squared divided by r squared is 1. So you notice that this is 2 terms. And I would just keep repeating this process over and over and over again. I can tell you that the common term here is 7t to the third. You notice that 3, 5, 4, the exponents on the t's, 3 is the smallest. 14, 42, 49, they're all multiples of 7. So we'll be left with 2 minus 6t squared minus 7t. And I would repeat the same thing here. Okay, you notice that there's p's, but the lowest p is p squared. And these numbers are all multiples of 11. So it's just 11 p squared on the outside. And I would be left with 5 minus, those 11s cancel out into 1. So I can write 1 p squared plus 4 p to the third. So that's left with my trinomial. And here, 1428, you might be thinking factors of 14, but there's that invisible 1 there, so I can't pull anything out of there. What I can pull out of here, if I can add an exponent of 1 there, I'm going to pull out a y, 14 y squared minus 28 y to the first plus 1. Remember, there are 3 terms here, so therefore there are 3 terms in the parentheses. The other way of factoring, and this happens when we have 4 terms, is to factor by grouping. And we do it exactly how we say it. Okay? We group pairs of terms and factor out the greatest common factor. So this only happens when we have 4 terms or an even number of terms. So in this case, all of these have 4 terms. And what we do is we group the terms together. So we group the first 2 and the second 2. Now we take the signs with them. And then we look, okay, what is common amongst these first 2 terms? Well, this is x squared and this is x. So an x is common. What would be left in those? Well, x plus 2. Okay? Now, what is common in here is kind of invisible. What you have to remember is there's a 1x in there. So really, there's nothing common between an x and a 2 other than a 1. So we can factor out a 1, and that's an x plus 2, in there. So if we take out a 1, we have to pretend to kind of take out a 1 there. Now what you notice, if you factor by grouping correctly, that inside the parentheses should be the same. So what we can do is we can then combine these two parentheses into 1, and then these numbers on the outside into another parenthesis. And now we're left with that quadratic setup where we would double distribute, and our next step would be here. Okay, so our whole goal is to get it into this term so then we can start solving for stuff. Again, this takes a little bit of practice. So again, we're going to factor the first two terms, okay, in the second two terms. What is common here? Well, you notice y squared and y, and 6 and 4. So what is common between 6 and 4? Well, there's a 2 and a y. What's left in there? A 3y minus 2. Now, is there anything common between a plus 3y and a minus 2? No. So when there's nothing common in there and you're factoring by grouping, we're going to factor out a plus 1. And you'll notice that this parenthesis becomes 3y minus 2. Now these two parentheses are the same again, so I'm going to take the numbers on the outside, the 2y plus 1, I'm going to make it one parenthesis, and the 3y minus 2 into another. Now for 15, there's a little bit more with it. You'll see where it doesn't have a plus 1 there. First two terms have a 4m in common, m squared and m, and then the two 4's, so I'm going to factor out a 4m. What's left is going to be an m plus p. I'm running out of room. What's common in here is a 3 and a p. So they don't have to be common to each other. This number outside does not have to be common amongst the two parentheses. What's going to be left inside the parentheses is going to be the same. So we factor out a plus 3 p. Inside the parentheses, if I take it out, the 3 and the p is m plus p. You notice m plus p is now the common parenthesis here. And then it's 4m plus 3p is the other parenthesis. Again, it's going to take a little bit of time to get practicing with this, looking at it as two different parentheses. So again, 12 ax plus 3xz is going to have a common 3x. What's going to be left is a 4a plus z. Here, in this case, plus 4ay plus yz, you notice that the y's are the same. So I'm going to take out a plus y, and you're going to get 4a plus z. Again, those parentheses are going to be the same. So my answer is 3x plus y times 4a plus z. Now, 17 is a little bit more tricky because it deals with negatives. So when I group these, you notice that the 12a squared and the 3a have a common 3a. So what's left is 4a plus 1. Because again, I took out that whole 3a, so 1 is left over. Now you have to look, okay, what's common here? Well, between 8 and 2 is 2. And there's no a's, so I know there's going to be an a left over, or a 4a left over here. Now, I know I want this second parenthesis to be 4a plus 1. I know that. I want these two parentheses to be the same. But if I just take out a 2, I'm going to still leave in the negatives. So when you see the negatives, you sometimes have to factor out so that these parentheses are the same. So sometimes you have to change the signs there. So now I have the parentheses the same, so it's 3a minus 2 times 4a plus 1. Okay, and for the last example, I can tell you the answer is going to be a plus 1 times x plus y. Because there's an a common here and there's a 1 comma here, so those are going to be my two parentheses. And that's how you factor a polynomial. So practice that first side of 8.5 study guide, and then when you're done with that, watch the video on solving polynomials using factoring.